Welcome everyone. Myself Prathamesh from Anna Sahib Dange College of Engineering and Technology, Ashta. Currently, I am studying in third year. My branch is Electrical Engineering. I welcome you all in this seminar session. I would like to thank you, our guide Mr. Sagarpati sir, for his guidance and coordination. So let's begin. My seminar topic is relays. First, we will see the introduction and basic information about relays. Relay is an electrically operated switch. Many relays use an electromagnet to mechanically operate a switch, but other operating principles are used as such as a solid state relay. Relays are used where it is necessary to control a circuit by low power signal or where several circuits must be controlled by one signal. The first relay were used in long distance telegraph circuit as amplifier. They repeated the signal coming in from one circuit and retransmitted it on another circuit, a type of relay that can handle the high power required to directly control an electrical motor or other loads is called as a contractor. Then we will see the principle of relays. A relay may also be called as an electromagnetic switch. Relays use low amperage circuit to control a high amperage circuit. The low amperage circuit controls an electromagnetic device. The electromagnetic device closes or opens the high amperage circuit. Then we will see the operation about relay. A simple electromagnetic relay consists of a coil wire wrapped around a soft iron core, an iron yoke which provides a low reluctance path for magnetic flux, a movable iron armature, and one or more sets of contacts. The armature is hinged to the yoke and mechanically linked to one or more sets of moving contacts. It is conditioned one of the two sets of contacts in the relay picture is closed and the other set is open. Other relays may have more or fewer sets of contacts depending on their function. The relay in the picture also has wire connecting to the armature to the yoke. When an electric current is passed through the coil, it generates a magnetic field that activates the armature, and the consequent movement of the movable contact either make or breaks a connection with a fixed contact. If the set of contacts was closed when the relay was de-energized, then the movement opens the contacts and breaks the connection, and vice versa. If the contacts were open when the current to the coil is switched off, the armature is returned by a force approximately half as strong as the magnetic force to its relaxed position. Usually, this force is provided by a spring, but gravity is also used commonly in industrial motor charter. Most relays are manufactured to operate quickly. In a low voltage application, the reduce noise. In a high voltage or current application, it reduces arcing. When the coil is energized with the direct current, a diode is often placed across the coil to dissipate the energy from coalescing magnetic field at deactivation, which would otherwise generate a voltage spike dangerous to circuit components. Then we will see the types of relays: latching relays, induction relays, reed relays, mercury weighted relays, solid state relays. Then we will see the operation of latching relay. A latching relay is also called as impulse relay. Maintains either contact position indefinitely without power applied to the coil. The advantage is the one coil consumes power only for an instant while the relay is being switched, and the relay contacts retain this setting across a power outage. A latching relay allows remote control of building lighting without the hum that may be produced from continuously energized coil. This type is widely used where control is from simple switches or single-ended output of control system, and such relays are found in avionics and numerous industrial applications. Then we will see the induction type relay. These are used as protective relays in AC system alone and are usable with DC system. The actuating force for contacts movement is developed by a moving conductor that may be a disc or cup through the interaction of electromagnetic flux due to fault currents. These are several types of like stated pole, watt hour, and induction cup structures and are mostly used as directional relay in power system protection and also for high speed switching operation application. Then we will see the reed relay. Reed relays can switch. A reed relay is a reed switch enclosed in solenoid. The switch has a set of contacts inside and faster than larger relays and requires very little power control circuit. However, they have relatively low switching current and voltage ratings, though the needs can become magnetized over time, which makes them stick on even when no current is present. Changing the orientation of the needs with respect to the solenoid's magnetic field can resolve this problem. Scared contacts with mercury weighted contacts have long operating lives and less contacts chatter than any other kind of relay. Then we will see the mercury weighted relay. A mercury weighted relay is a form of a reed relay in which the contacts are weighted with mercury. Such relays are used to switch low voltage signal where the mercury reduces the contact resistance and associated voltage drop for low current signals where surface contamination may make for a poor contact, or for high speed applications where the mercury eliminates contact bonds. Mercury weighted relays are position sensitive and must be mounted vertically to work properly. Because of the toxicity and expensive of liquid mercury, these relays are now rarely are used. Then we will see solid state relay. A solid state relay or SSR is a solid state electronic component that provides a functional similar to an electromechanical relay but does not have any moving components, increasing long-term reliability. A solid-state relay uses a thyristor, triac or other solid-state switching device activated by the control signal to switch the control load instead of solenoid. An optocoupler can be used as isolate control and control circuit, as every solid-state device has a small voltage drop across it. This voltage drop limits the amount of current given in SSR can handle. Then we will see the advantages of relays. Electromagnetic relays have fast operation and fast reset. They can be used for both AC and DC system for protection of AC and DC equipments. They have the properties such as simple, robust, compact and most reliable, and these relays are mostly instantaneous. Then we will see the disadvantages of the relays. The directional features is absent in electromagnetic relays, requires periodic maintenance and testing unlike static relays. Relay operation can be affected due to aging of the components and dust pollution resulting in spurious strips. Then we will see some applications of the relays. Electromagnetic relays are employed for the protection of various AC and DC equipments. The over or undercurrent and voltage protection of various AC and DC equipments for different protection used as auxiliary relays in the contact system of protective relay scheme. Then we will see the conclusion. This was touched on before but it's worth special attention. Remember that certain devices requires considerable current. High current device requires big, heavy switch to handle the current. Unfortunately, this would be ugly and expensive, so engineers are relays. Protective relays are essential for keeping faults in the system is isolated and keep equipment from being damaged. Thank you everyone.